Welcome to the very first session of our new AWS Research IT training series, which offers free training engagements geared towards research IT professionals. I'm Marcy Collinson, your session correspondent and the Senior Scientific Research Programs Manager for the AWS Research Team. Today, we are delighted to have Dr. Lisa McFerrin, Senior Bioinformaticist at AWS, where she leads initiatives supporting the genomics industry as part of worldwide business development. Prior to AWS, Lisa worked at Fred Hutchinson Cancer Research Center, where she specialized in the development of software and methods that bridge genomic and clinical data to advance the understanding of cancer biology and improve patient care. In these roles, she facilitates collaborative and reproducible research in order to lower the barriers in communication, analysis, and sharing of data, knowledge, and methods. Lisa has a background in math and computer science and obtained her PhD in bioinformatics from North Carolina State University. Today, Lisa will be offering an introduction to AWS for Research IT. We will reserve the last 5 to 10 minutes of the session for a Q&A portion, but please feel free to place any questions that you may have during the presentation in the questions queue in the GoToWebinar toolbar, and we will read them aloud later on. So without further ado, I will pass the microphone over to Lisa. Lisa, please take it away.
Thank you, Marcy. And thank you, everybody, for joining us today. As Marcy described, I'll be talking about just kind of an introduction to AWS for Research IT, walking through the major pillars that help IT organizations support their researchers and support their organizations. So I wanted to start off by really focusing on the research aspect and how we can enable the environment and the individuals involved with it. One of the main points is to focus on the science rather than the servers. What is the application and use that your organization is focusing on, and not necessarily the compute infrastructure. And that's where AWS can help support for managing the IT, whether it's an enterprise business or academic research, to reduce the friction in resources, to automate and share pipelines, to enhance capabilities, and ultimately to reduce the human and the compute time in these types of trivial tasks. AWS helps support access to the compute instances for on-demand resources and provide the scalability for the type of research needs necessary. And also to help support collaboration, whether it's finding files and being able to understand what data has already been generated within your organization for individual projects or environments, to being able to share those within organizations and across organizations and spanning those institutions. Also looking to be able to help support open data access and collaboration so that there's not the need to reproduce data along the way, but to utilize what is already available. This helps largely to share the effort, being able to leverage the work that's already been done, so not so much time is spent in terms of recreating and reproducing existing efforts that are unnecessary. Reproducible research is clearly important, and being able to replicate original findings is foundational to the field, but there are the scientific reproducible components of that, and then there are just the pure infrastructure parts that may get in the way. So being able to use the GitHub repositories or containers and a common environment to be able to accelerate that helps the researchers pick up where others have left off, and prevent knowledge from walking out the door when maybe a postdoc or student graduates, and be able to leverage that knowledge within the organization. Utilizing AWS can also help accelerate that science by adopting state-of-the-art analytics. Being able to run benchmarking in the cloud and take those studies that have been previously run, scale the data to the type of size and capacity that's needed, and run those machine learning tools that can help better understand the predictive analysis as well. And clearly foundational to all of this is the security to help your organization and provide that trust that what data is being generated, what tools are being developed, all lives in-house and has the proper permissions as necessary, but still enables that collaboration and regulatory and compliance that you're looking for. So I'm going to start off by diving into the core infrastructure of how we help enable those key factors. And wanted to start off by just commenting on AWS as the largest global infrastructure footprint with over 22 geographical regions, 69 availability zones, and an ever expanding and constantly increasing footprint to help you where your research resides, but then also to collaborate with those other organizations more globally. Within each AWS region, there are multiple availability zones. Each availability zone has physically separate data centers, and it's this type of capability that allows for high availability, high scalability, and the fault tolerance that allows for things like S3 to have 11 nines of durability when you're looking to store data because it is replicated across these different data centers. Each region also has 2 independent, fully redundant transit centers that allows for the traffic across the AWS network to enable the regions to connect globally. So as far as core services, I'm going to walk through 4 major ones. This is foundational to AWS, but ultimately we work with organizations to continue to innovate in this field and develop out more managed services that meet your business needs. The first core competency we have is within compute and being able to run EC2 instances and manage that compute and memory capacity, and leveraging the data storage mechanism for those basic analyses, and transform that data and store it in a highly queryable way, whether it's structured or unstructured, in relational databases or DynamoDB, all, as I was mentioning before, with the proper security and governance, using our identity access management for the researchers and roles and permissions to be properly provisioned. And each of those 4 competencies and all the managed services on top of it should be viewed as a utility. The goal here is for AWS to be viewed as on demand and fit for purpose, where you can turn these types of services off and on as needed and only pay for what you use. That way you can focus on your applications and what matters to your business, and not the infrastructure and the cost associated with what would be needed for the maximum type of project you need. Being able to scale at the capacity as needed for those projects and those maybe needy type of researchers that you're working with in your organization. So to dive into the compute component here, just wanted to highlight our EC2 instances, as well as our container management and our service applications. What we do here is deliver choice for whether it's your existing needs or new applications according to your business. EC2 has over 270 instance types, working with Intel for faster processors, accelerating compute, and removing network bottlenecks for HPC. Just a quick diagram on some of our instance types. There are those that are general purpose, for maybe your small compute and micro type that are part of our free tier, or those that are necessary for the more demanding type of workloads, whether it's compute, memory, or storage. There's also our accelerated computing instance types, including our GPU and FPGAs. And I wanted to call out a particular case study we have. I come from the genomics background, so this one's special to my heart in terms of being able to accelerate genomics processing for better understanding how your DNA can contribute to diagnostics and any type of disease capabilities. So Children's Hospital of Philadelphia worked with Edico at the time, now Illumina's Dragon Genome Pipeline, and were able to set a world record to be able to analyze 1,000 pediatric genomes and process them in 2 hours and 25 minutes. And the key here is that they were using our F1 FPGA instance types that basically allow software to run as hardware, that accelerated this data processing and allowed for the knowledge of how the genome may better inform that, that patient and that clinical treatment pipeline as quickly as possible, which is key, I'm sure you can imagine, in these types of hospital settings. So for instances and applications like that, it's likely that you'll want to be able to have these spiky workloads address needs of these batchy compute lines and have on-demand pay for compute capacity. This is managed by the second with no long-term commitments, allowing you to expand your compute resources as needed, and then again scale that back down to only pay for what you use. For other types of workloads that you're running where it's better known what type of commitment and steady state usage you'll be applying, that's where savings plans and reserved instances can come into play, where the commitment you make to use those based off of that need can offer a significant discount. In addition to that, when you may have these spiky workloads and also look to have savings up to 90% of this compute capacity, the spot instances allow you to access the extra capacity within our data centers and run fault-tolerant workloads that basically allow you to take things that are maybe loosely coupled or stateless, run these pipelines, and for types of instances where the compute may be preempted, but ultimately the data can be stored and you can recapture maybe that file input and output and regain that workload easily while saving that on-demand price, again, up to 90%. So ultimately, what we're covering here is the customer centricity of being able to support your compute needs with the right resources and focus on only that which you are using to grow and shrink your infrastructure as needed. We want to offer the flexible configuration and unlimited scalability, focusing on those research applications. And so wanted to walk through a bit of the different ways that containers are being applied in this space. Largely the reproducibility we were talking about in research and scientific applications is critical for being able to recapture what is done, to be able to share and publish it, and to be able to expand and collaborate with other organizations. And so containers are a useful way of being able to capture that compute environment. We offer Elastic Container Service to be able to deploy, schedule, scale, and manage these container applications, as well as our Kubernetes, of which 60% of Kubernetes workloads are run on AWS today. This is entirely an organic growth fueled by the strong community of developers, customers, and partners that are finding the value in being able to run Kubernetes on AWS for these coupled types of computing and environment workloads. When you're looking to understand where to run those containers, you can either specify those based off of the EC2 instance types I described, or you can run it as a serverless approach using AWS Fargate. Using Fargate, you can bring your existing Kubernetes pods and run across multiple availability zones for high availability and include all the AWS integrations for the networking, security, and right-sized computing to fit your needs. All of this is also integrated with our Elastic Container Registry. This is helpful to be able to store and capture those compute environments, but these offerings also work to be able to reach out to other container repositories like DocStore and use those scientific community-driven efforts. Just to dive a bit more into the Kubernetes offering, there's global availability in multiple regions, reduced initial costs with the rapid deployment, and the easy control plane management. So won't talk too much more about that. But I did want to talk also about not just the distributed computing approach and the need to have these clustered environments, but also how to manage the types of jobs that may be highly parallelized. For the job schedulers that you may be used to and the HPC environments on premises, you can use things like AWS Parallel Cluster to integrate with these schedulers. There are burstable jobs capabilities for on-prem, including HT Condor or your Slurm scheduler that you can run in parallel cluster, also integrated with our additional AWS services, or the AWS native job scheduler, which is AWS Batch. This involves no additional components to install and dynamically provisions all the resources, schedules, and execution management based off of the compute environment that you can define and the type of instance and resources that meet your compute and memory needs. Now, to shift a little bit, that was discussing a lot of the capabilities for what the compute looks like, but all of this also sits upon and is well integrated with our storage mechanisms, largely discussing S3 here, to be able to cost optimize where that data resides. If you have certain type of workloads that the data and object types are frequently accessed, you'd want to be able to put that data within your S3 standard bucket. But for those that maybe aren't accessed as widely, and you may not know which file types those are, and you want to reduce the cost for the storage over the long term period of this, you may want to apply intelligent tiering so that the storage of those files can automatically transfer to the different storage types, whether it's our infrequent access, one zone infrequent access, or Glacier or Glacier Deep Archive. And so what the lifecycle policy allows is for your S3 standard data to maybe move into the infrequent access, ultimately into your S3 Glacier, or into your Deep Archive. And at least from the genomics perspective, Deep Archive is highly useful for data archiving, especially for the clinical data that needs to be stored for 7 years within the US for auditing purposes, so that the large scale files of genomics data, you're only paying for about $1 per terabyte per month. So it's really useful to be able to manage the access frequency, but still be able to recover this either for disaster recovery or long-term archive. Also wanted to comment a bit about FSX for Lustre. Just as many organizations that are maybe evaluating AWS compared to your on-prem solutions and what the different schedulers may look like, there's also the different file storage mechanisms. FSX Lustre allows you to have sub-millisecond latency for scalable performance and data integration, allowing you to hydrate your compute instances with that data backed by your S3 data storage, and offers this within the native file system interface that you may be familiar with, like a POSIX file system, allowing you to have the secure and compliant infrastructure that is cost optimized and well integrated to your larger types of workloads. And so to move along, I wanted to now touch upon security and compliance, which I'm sure is of high importance and can be one of the most complex elements of your operation. There's a high degree of interconnected systems you may need to manage, a wide range of hardware vendors that you're working with, and all of this may make it difficult for visibility into the types of activities or the possible threats that are going on within your IT organization. From experience, it may be difficult to look at the number of firewall holes you've punched in and who is overseeing those relationships and how to manage that over time. So this is where AWS can help support based off of our experience with managing the security layer involving over 50 compliance certifications, having security teams and different types of services to be able to monitor and configure and alert of any type of configuration changes, that may be ongoing within the infrastructure, but then also just the actual infrastructure and the data centers that military, government, and high sensitive organizations trust us with to be able to manage their data and their mission critical applications. Ultimately learning from these 1 million plus customer experiences to continually enhance their security offerings and enable all organizations to be able to benefit from these types of implements. The way that AWS looks at security, though, is through the lens of a shared responsibility model. AWS is responsible for security of the cloud, while customers are responsible for the security in the cloud. And so what this diagram is looking to represent is the different types of views of what that means. So for the AWS side, we are responsible for the regions, the availability zones, the locations, and the hardware, as well as those services that we offer, whereas the customers then are responsible for the types of applications and how they implement the identity and access management on top. But ultimately, while there is this responsibility model that is shared, AWS also offers a number of best practices, partner applications, and ways that we can work with you to ensure that you are implementing the best security model to fit your needs. We work with a number of compliance programs and offer the regulatory and certification offers here. Within the United States, we have over 100 HIPAA eligible services, of which, again, those best practices can help you implement these compliant infrastructures for your organization. Now, all of this may seem a bit overwhelming of all these different services and applications and configurations, especially if you're looking from a security perspective of how to bring this all together. So that is where offerings like the Research Landing Zone can help you use AWS organizations and set up these types of infrastructures and architectures to enable the security, the logging and archiving, and these different environments that allow your research to have sandboxes and migrate from your pre-production and staging to production systems to better enable both your core services as well as those on-demand or project-specific needs. And as you may have new projects coming on and new individuals joining your organization, there's the account vending machine that can help onboard, create and update AWS accounts, be able to apply the proper security roles to them, baseline those accounts, enable the logging and archiving with the auditing of buckets, and also creating those shared services so that they have access to the proper resources, but within a transparent but guardrailed environment that your IT organization can help provision. So the fun questions also fall into billing and costs. What does this actually mean to adopt? When will you be billed? Where are your costs? And what options do you have to bring those down? So wanted to just highlight some of the tools we have to help address those questions and concerns. There are billing and cost management services that help you budget, monitor, and manage the usage with clear dashboards to help you understand where you're at and what's being used. And a cost explorer that provides an easy-to-use interface to manage these costs and usage over time. These dashboards will allow you to get started quickly and save your progress and access the data programmatically. But importantly, it also allows you to understand the intervals, granularity, and forecasting based off of the different types and groups of your data and users. AWS budgets may also be important for your organization if you have fixed budgets and maybe grant-based projects you're working off of. And this can allow you to alert when you're exceeding your budget thresholds and track these usage costs over time, regularly updated 3 times a day, and integrated with any kind of notification service so that you can have rapid access to this type of information rather than see this type of data at the end of the month. So moving along fairly quickly, I know I'm giving you lots of information, but happy to take questions at the end. I wanted to now pivot to what does all of this bring? You know, there's the core infrastructure and the IT component, and ensuring that the comfort level of permissions and security and compliance are all in place. But what we want to do is enable that research. So what are those analytics and AI ML services that AWS builds upon that core infrastructure to help accelerate that science? And ultimately, at least the way I view this is through data. It's garbage in, garbage out when you're talking about any type of analysis and being able to access the right data with the right information and tagging, and be able to get at it easily, rather than maybe recreating it or losing that understanding and traceability and provenance of how it was managed. So having full visibility into that data for the proper use in your analysis is key, and also for the data sharing and reproducibility of that science. So this is where data lake architectures come into play. It brings in the best of both worlds of being able to access that data and easily integrating it into those compute services and that managed layer for analysis, whether it's the data warehousing, standard analytics, or the machine learning layer, being able to manage data in any type of format. Need to make sure that it is properly tagged to make sure it's a data lake, not a data swamp, but then also layer on that security and compliance and auditability so that the analytics and predictive analysis can be accessed by the right users. And so this is where we offer the analytics portfolio, from the data layer at the bottom, which may be foundational to your organization and what data is produced and accessed and utilized, the accessibility of that through the infrastructure and management, and then enabling the analytics on top of it, ultimately for that learning and visualization and engagement with those users. We have a number of AI services that I'll just touch upon here, from image analysis to NLP and forecasting and dashboards, as well as being able to launch Python notebooks within SageMaker for your data scientist, or maybe launch RStudio for data scientists to be able to run those types of methods and algorithms within that environment. Within the analytics layer of this stack, there is Amazon Athena. The reason I wanted to talk about this is because it's a serverless yet interactive way to query that data. Again, once you have the information and files or objects stored, it's a regular problem to say, where did I put that? Or what was this from? Or how can I integrate this data set with this other data set, possibly coming from another PI within a principal investigator in your organization, or otherwise. So what Amazon Athena offers is the ability to query these data objects within S3 at zero setup costs, utilizing the data catalog, only paying per query, 30 to 90% on per query costs through compression, integrated within your S3 data store, and again, hopefully easy to set up with the serverless, zero infrastructure and zero administration to understand what data is available. And then from accessing that data, it's then what can you do with it? What are those analyses and applications that you're looking to run? And many of them may require this type of distributed computing or the elastic MapReduce service we offer that allows you to easily run Spark, Hadoop, Hive, Presto, these big data apps. We update them within 30 days for each of these latest versions, offer them at a low cost, again, integrated with our S3 data storage, and using a fully managed no cluster setup so that it reduces the IT burden for these researchers to be able to get up and running. And I'd be remiss if I didn't speak to our AI and ML stack. This allows researchers to basically integrate at the different layers of their depth. You may not have data scientists at your organization that will want to work at the code base level, but want to access different types of trained services and deployable models, or be able to use our AI services from image analysis for tumor detection, or to use our translate mechanism for different types of publications. Or being able to have our speech and chat bots as well. So there are a number of AI services that can help with that initial layer and console access, maybe for the more novices, but then there are also the ML services that allow you to build, train, and deploy these models. These may be apps in computer vision, language, recommendation, and forecasting. And also be able to layer in their own models using the frameworks. TensorFlow is one of the more popular ones, and it runs on AWS as well as the other frameworks. And the idea here is for this to have the deployable models with minimal effort and access to these tools. Models that may take months and specialized experts can be built in weeks or days, such as what Intuit did, being able to pull years worth of bank transactions to find deductible business expenses for customers and reduce that development time from 6 months to 1 week, ultimately a 90% reduction in time. ML also requires the security and data store, analytics, and compute services to work together. So we include the capable, reliable, secure, and fully featured data lake that's integrated within our ML stack, as well as the HPC and robust analytic capabilities, as well as the accreditations that we discussed before. One example of the ML application as well is that which was done by the University of Illinois at Chicago. They looked to model the Hurricane Harvey predicted path, and as you can see by these images, it had a high level of accuracy in where the path went, and being able to classify the crisis related to social media and using our AWS Comprehend service for NLP. As I was mentioning as well, that there are the data scientists that may not have their own knowledge of being able to build out these ML services, or maybe they do and just are aware of some of the top tier types of applications being run. So we offer our algorithms and model marketplace for you to be able to pull these types of models in addition to our container repository and our AMI, or Amazon Machine Image, and our EC2 service to be able to access the types of data and compute and environments that have been pre-established so that you can bring them into your own environment and, again, pick up where other scientists have left off and be able to continue to accelerate that discovery process. Moving on to the research gateways and scientific solutions, just wanted to again comment that we are well aware at AWS that we continue to innovate at a rapid pace and create a number of broad choices, from our data management to our types of compute infrastructure and our services and managed implementations. And this can be overwhelming for our users. You can go to the console and be able to search and implement, or you can use our SDKs behind the scenes and our APIs. But again, it may be difficult to navigate and implement broadly. This requires organizations to implement the security policy that may be time consuming, incorrectly tagged, or have cost overruns if not viewed and addressed early. And so the question becomes how to properly provision the right resources for the right users within your organization and manage those conditions. And so this is where our self-service with preconfigured compliance and CloudFormation templates come into play. This allows you to utilize our AWS services, whether they are customer created and AWS based, or those from the marketplace and third-party products like those that I just mentioned, and be able to use either CloudFormation, which is our AWS infrastructure as code, or Terraform templates that can help automate and enable these types of constraints and provide the transparency layer on top of it, so the administrator is able to standardize best practices, understand those roles and permissions of those users, and be able to offer service catalogs on a role-based level for those individuals in your organization so that they have access to the compute resources they should and the data and needs, while still having that governance and guardrails, and again, that visibility from an organizational level for that cost transparency as well. There are a number of partner research gateways to also consider. You can do it your own workloads, but if that's not your thing, there are a number of partner and open source community offerings, whether it's from the Ronin dashboard to others that can help you view what the project-based workloads are and have that dashboard visibility into how resources are being utilized, and again, that billing transparency and collaboration portal. So I just wanted to wrap up a bit on the collaboration and the ecosystems. Science is often not an individual reductionist approach anymore. It can be a team sport with a number of individuals coming from different backgrounds and expertise being able to contribute to some of these cutting edge technologies. And I'd argue that many of the really cutting edge applications are those that come from the intersections of different fields. And so taking the traditional approach of data into these individual silos and moving the data to computing is no longer viable, especially for the size of data that is being generated, whether it's from the geospatial or the genomic. It's difficult to track what data and security exists by moving it. It's also time consuming and cumbersome to then manage it using this approach. So what the cloud offers is being able to offer these integrated services and move the compute and those resources to the data with the integrated approach of the provisioning and permissions as well. You probably heard me mention S3 several times being integrated with these services. And again, that is one of those foundational layers of where the data and the objects may reside, and then be able to layer on the access and capabilities and analytics on top of that. One initiative that also sees this as a bit of the way of the future is the STRIDES initiative for the science, technology, and research, ultimately to drive the discovery, experimentation, and sustainability of the data, the tools, the services, and leveraging the cloud for that computational infrastructure. AWS joins STRIDES and is happy to work with them on a number of the data projects and the researchers and organizations that are building upon the learnings towards this goal. The data layer, again, I think is critical to this, especially to not recreate data that already exists and be able to enhance the learning and capabilities of your organization. Utilizing what is already known and contributing even further to it. So that is where the Open Data program comes into play. The goal of it is to better enable the scientific community through communities of practice and collaboration and access to these valuable data sets. Examples where we work with these data producers to cover the hosting cost and enable the broader community to be able to access and integrate this data within their own analysis include genomic data like the 1,000 Genomes Project or the Cancer Genome Atlas, as well as broad levels of weather and geospatial data and other types of industry-specific applications. I focus on genomics and life sciences, and there are over 40 data sets to help contribute to a hypothesis exploration, development of your compute applications and testing against existing data sets, and then the innovation that can lead to future discoveries. Now, the Open Data program is one way to access these public hosted data sets, but there are also use cases where you want to do one-to-one or one-to-many type of sharing for producers to be able to offer data within a marketplace. And so the AWS Data Exchange allows subscribers and providers to quickly be able to manage that data transfer and capabilities by finding the diverse types of data in one place, moving that within the S3 and AWS infrastructure to analyze it and get up and running for the applications. And again, being able to have all the built-in security, compliance, and controls around it. Now, for data that is not something that you want to have long-lived on AWS, if there are certain reasons or applications that you find that it's necessary for it to be migrated off, we wanted to be able to support those researchers and those applications. So there's no cost to upload data to AWS, but we are committed to these researchers and academic organizations to make the cloud easy and accessible. And if there are these instances where data does need to be egressed, we can work with you to grant egress waiver charges for these data downloads over the internet, and work with your account manager for these research portals or resellers and manage that data locality for you. So just to start wrapping up, wanted to also highlight the AWS Educate and Research Credits program. Again, wanting to help support organizations get started, trained and up and running on the cloud, whether it's through research grants or these trainings and curated content that can help you and your organization. And so with that, I'd like to thank you for your time. If you wanted to follow up with the AWS research team about any of these topics, the email is provided here. And I believe I'll hand it back to Marcy and take any questions.
Thank you, Lisa. What a wonderful presentation. I'd like to encourage the audience that if you have any questions you'd like to ask Lisa right now, live during the session, please go ahead and put them in the questions queue. We do have a few questions, so I'll start at the top. How do I help researchers keep data private, but also enable sharing for collaboration?
Yeah, that's a big one, especially with understanding the researchers' permissions and capabilities. So there's always the fear in innovation that researchers are onto something and their data is their data, and rightfully so. So this is where you can operate the identity management where those researchers only have access to that data, and it's ultimately up to you. AWS never looks inside your S3 bucket. The data that lives there is at the utmost security level just by default, and then organizations can manage how that data is accessed and provide that flexibility for additional collaborations as needed. So as researchers are running their analysis and have their private data set set up, they can then move that derived data still to that bucket and have that secured access there. And as data maybe becomes more accessible to collaborators or the broader community, you can then toggle those permissions and enable the broader discovery of that data, really through an easy interface to be able to do so. But still using managed services to ensure that that type of toggling and switching isn't being done too early or unnecessary, or the people who have the right permissions are the only ones able to do so. Using things like control tower or config are good ways of organizations being alerted of any of those changes to S3 buckets or any type of our compute services and permissions.
Great. Next question is, how do I train my staff and researchers on AWS services or provide dashboards to get up and running quickly?
Yeah, AWS approaches working with organizations as a partnership. This presentation was just an introduction and frankly probably a whirlwind of just some of our services. And so we want to work with you to understand what it is that you're looking to accomplish as an organization, as a researcher, and how we can help you get there. I work very closely with the healthcare, life sciences, and genomics industries within their line of business of how to help understand how data and analytics can support cancer research. And so there are individuals within AWS happy to dig in with you and understand how it is we can help. So first contact would be your account manager and work with those individuals to bring on the additional resources that we have. Whether it's this broadcast level training and virtualization of education and awareness, or more hands-on implementations like immersion days, where different solution architects may be able to work with your organization, bring on the different business teams that you have, and focus in on the services that are particularly applicable to your use case and how it may be implemented at your organization. So there are a number of ways that we can work with you and help get you up and running, whether it's through these types of offerings and free services, or to work with our professional services organization as well for particular projects where you want AWS to come in and be hands-on in terms of how it gets up and running within your organization and your architectures.
Wonderful. Next question is it safe to store PHI/PII data on AWS?
Yes. So we work with a number of organizations within the healthcare and life sciences space and more broadly that trust AWS with their mission critical data as well as their most sensitive and secure data. We work with Cerner, who is a medical record system that has over 3.5 million lives represented on AWS. And with that said, it is our business to make sure that that type of data is secure and has all the infrastructure and support to be able to make sure that it is properly maintained and operated. Again, there is that shared security model and responsibility mechanism of the in the cloud versus on the cloud, but we work very closely with organizations that find this as more secure than what their local data center would be because of the number of services and the type of baseline security architecture and infrastructure that AWS provides as a baseline and then all the machine learning capabilities to monitor and alert and be aware of any types of threats moving on top of it as well.
Great. Do you have industry-specific expertise to help with data analysis and machine learning?
Yes, I am one example of that. We have a number of industry-specific applications. So whether you're looking at the healthcare genomics and life sciences space, agriculture, automotive industry, consumer product goods, just there are the full litany of different types of industries and applications that you may be addressing as an organization. And where AWS sits, I started off by talking about our core infrastructure and what may look like just a vendor service of data storage and compute. We really like to focus on the business opportunities for your organization. What is it that your mission is that you would like to accomplish? And what are those goals, and how can we work together to work backwards from those goals, understanding that vision and then implementing the technology to help enable that. What level of automation can we apply? How can we reduce any of the friction or barriers that you're encountering and help accelerate that science and that application? So whatever your business may be and whatever subject matter expertise is involved, I encourage you to reach out to us and help work with us to think of how we can change and innovate in that space. It's a pretty exciting field, and I think that there's a lot that can get done. The pace and innovation of AWS, coupled with the really bright minds of these different industries and organizations, hopefully can make a big change. I hope to do so in the healthcare world and how genomics can be utilized for it.
Wonderful. Thank you so much, Lisa. I'm sending everyone a link to our homepage for the AWS Education Research Seminar Series. I just wanted to bring to everybody's attention that we will have our next session coming up, which will actually be about NIH Strides, or the NIH Strides initiative that Lisa mentioned earlier during the presentation, and it will be NIH Strides, Biomedical Research in the Cloud. And once again, STRIDE stands for Science and Technology Research Infrastructure for Discovery, Experimentation, and Sustainability. The session will have 3 separate presentations by representatives from the National Institutes of Health, AWS, and 4 Points Technology, and will be held on August 26th from 9 o'clock to 10 o'clock a.m. Pacific Standard Time. So please be sure to register once that registration link is live on that page. Regarding our next session for the AWS Research IT training series, you will receive an email about our next session in a few weeks, which will be about the use of serverless Jupyter notebooks with Dr. Zhenjun Zhu, who's a senior solutions architect at AWS. If you have any additional questions about this session, or if you would like to make a suggestion about upcoming topics, please contact us at that alias that Lisa pointed you to, aws-wws-seminar@amazon.com. Once again, I'd love to thank Lisa McFerrin. You did a wonderful job, such an interesting presentation about a broad range of what AWS can do for the research IT community. So thank you again for your time and expertise. And we want to thank the audience for joining us today and look forward to seeing you again soon. Have a wonderful day.